Several potential causes of power supply failures are neutral return current interference, harmonic distortion and resonance, interaction between power supplies, and common mode noise. Connecting individual ground wires from the power supply chassis to the transformer neutral can create interference with the neutral return current path. This can lead to voltage imbalances and harmonic distortion on the transformer secondary, potentially causing power supply failures. The high harmonic distortion, around 30% from the induction heating power supplies, can create resonances in the distribution system. These resonances can amplify voltage and current distortions, leading to power supply failures. A large number, 50 to 100, of power supplies in close proximity can interact with each other through electromagnetic coupling. This interaction can cause harmonic distortion and voltage fluctuations, contributing to power supply failures. The floating nature of the power supplies creates a potential for common mode noise to enter the system. This noise can interfere with the operation of the power supplies, leading to failures. Recommended mitigation strategies include addressing the neutral return path, harmonic mitigation, isolation and shielding, and the grounding strategy. To ensure a proper neutral return path, connect a single ground wire from the transformer secondary neutral to the cabinet of each power supply. Install power factor correction circuits to reduce harmonic distortion and improve power quality. Consider electrically isolating the power supplies from each other and shielding them from external electromagnetic interference. Optimize the grounding system to minimize common mode noise and improve overall system stability. Additional considerations include voltage and current measurement should be taken to verify the presence of voltage imbalances and harmonic distortion. A frequency analyzer can be used to identify resonant frequencies in the system. Electromagnetic compatibility testing can help assess the interaction between power supplies and mitigate potential interference issues. When troubleshooting power supply failures in induction heating systems, there are several key areas to investigate. Firstly, thoroughly examine the neutral return current path. The practice of connecting individual ground wires from each power supply chassis directly to the transformer neutral can inadvertently create multiple ground loops. These loops can become pathways for circulating neutral currents, leading to voltage imbalances and increased harmonic distortion on the transformer's secondary side. This distortion can disrupt the sensitive electronic components within the power supplies, ultimately causing them to fail. Secondly, consider the impact of harmonic distortion and potential resonance. Induction heating power supplies, by their very nature, generate significant harmonic distortion, often around 30% or higher. When a large number of these power supplies operate simultaneously, the cumulative harmonic distortion can create resonance within the electrical distribution system. These resonant frequencies can amplify voltage and current distortions, exceeding the tolerance levels of the power supplies and triggering failures. Thirdly, evaluate the potential interaction between closely spaced power supplies. In systems where numerous power supplies are installed in close proximity, electromagnetic coupling can occur. This coupling can lead to the transfer of harmonic distortion and voltage fluctuations between the power supplies. The resulting interference can disrupt the operation of individual power supplies and contribute to system-wide failures. Fourthly, address the potential for common mode noise. When power supplies are designed to be floating, meaning they are not directly referenced to ground, they become susceptible to common mode noise. This noise, which is essentially unwanted electrical signals present on both conductors of a circuit, can interfere with the internal circuitry of the power supplies, leading to malfunctions and failures. To mitigate these issues and improve the reliability of induction heating systems, implement the following strategies. Firstly, optimize the neutral return path. Instead of running individual ground wires from each power supply chassis to the transformer neutral, establish a single, dedicated ground wire from the transformer neutral to the main equipment cabinet. This approach creates a centralized grounding point and minimizes the formation of ground loops. Secondly, implement harmonic mitigation techniques. Install power factor correction circuits to reduce harmonic distortion and improve the overall power quality of the system. These circuits can filter out unwanted harmonics, preventing them from propagating through the electrical distribution system. Thirdly, consider isolation and shielding. Electrically isolate the power supplies from each other to prevent electromagnetic coupling and the transfer of harmonic distortion. Shield the power supplies from external electromagnetic interference using grounded metal enclosures. Fourthly, optimize the grounding system. Implement a comprehensive grounding system that minimizes common mode noise and ensures overall system stability. This may involve using dedicated grounding conductors, star grounding configurations, and other grounding best practices. To further refine your troubleshooting efforts, consider the following additional steps. Firstly, conduct voltage and current measurements. Use a high-quality multimeter or power analyzer to measure voltage and current levels at various points in the system. Pay close attention to voltage imbalances and harmonic distortion, which can indicate underlying problems. Secondly, perform frequency analysis. Employ a frequency analyzer to identify resonant frequencies within the system. This analysis can help pinpoint potential sources of harmonic amplification. Thirdly, conduct electromagnetic compatibility testing. Perform electromagnetic compatibility testing to assess the interaction between power supplies and identify potential interference issues. This testing can help determine whether additional shielding or filtering is necessary. By systematically addressing these potential causes and implementing the recommended mitigation strategies, you can significantly improve the reliability and performance of induction heating systems. Understanding the nuances of neutral return current, harmonic distortion, power supply interaction, and common mode noise is crucial for effective troubleshooting and long-term system stability. Carefully consider each of these factors when diagnosing power supply failures and implementing preventative measures. In summary, the key to resolving power supply failures in induction heating systems lies in a multifaceted approach. Firstly, streamline the neutral return path to eliminate ground loops and voltage imbalances. Secondly, mitigate harmonic distortion through power factor correction and filtering. Thirdly, isolate and shield power supplies to minimize electromagnetic interference. Fourthly, optimize the grounding system to reduce common mode noise. Finally, utilize diagnostic tools like voltage and current measurements, frequency analysis, and electromagnetic compatibility testing to pinpoint and address specific issues. By combining these strategies, you can create a robust and reliable induction heating system that minimizes power supply failures and maximizes operational efficiency. The interaction of these power supplies can cause a variety of issues, including harmonic distortion, voltage fluctuations, and electromagnetic interference. These issues can, in turn, lead to power supply failures and other problems. A thorough understanding of these concepts is essential for anyone working with induction heating systems. Remember to always consult with qualified electrical engineers and follow all applicable safety regulations when working with electrical systems. Safety should always be the top priority. In addition to the previously mentioned strategies, consider the following advanced techniques for mitigating power supply failures in induction heating systems. Firstly, implement active harmonic filtering. Active harmonic filters are sophisticated devices that actively cancel out harmonic currents generated by nonlinear loads such as induction heating power supplies. These filters provide a more effective solution than passive filters, which can sometimes create resonance problems. Secondly, use line reactors. Line reactors are inductive devices that are placed in series with the power supply input. They help to reduce harmonic distortion and improve power factor by smoothing out the current waveform. Thirdly, consider using a dedicated transformer. If possible, use a dedicated transformer to supply power to the induction heating system. This can help to isolate the system from other loads and the electrical distribution system and reduce the impact of harmonic distortion. Fourthly, implement a robust monitoring system. A monitoring system can track key parameters such as voltage, current, harmonic distortion, and temperature. This information can be used to identify potential problems early on and prevent power supply failures. Fifthly, perform regular maintenance. Regular maintenance, including visual inspections, cleaning, and testing, can help to identify and address potential problems before they lead to failures. Remember that the specific solutions that are most effective will depend on the specific characteristics of the induction heating system and the electrical distribution system. It is important to carefully analyze the system and consult with qualified experts to determine the best course of action. Also, always prioritize safety when working with electrical systems. Follow all applicable safety regulations and use appropriate personal protective equipment. Failure to do so can result in serious injury or death. Furthermore, consider the long-term implications of your chosen solutions. Some solutions, such as active harmonic filters, may have a higher initial cost but can provide significant benefits over the long term in terms of improved power quality, reduced energy consumption, and increased equipment lifespan. Other solutions, such as passive filters, may be less expensive initially but can potentially create resonance problems that could damage equipment. It is important to carefully weigh the costs and benefits of each solution before making a decision. In addition to the technical aspects of troubleshooting and mitigating power supply failures, consider the importance of communication and collaboration. Effective communication between engineers, technicians, and operators is essential for identifying and resolving problems quickly and efficiently. Encourage open communication and create a culture of collaboration where everyone feels comfortable sharing their observations and ideas. Also, document all troubleshooting steps, solutions, and maintenance activities. This documentation will be valuable for future reference and can help to prevent similar problems from occurring again. The documentation should include detailed information about the problem, the steps taken to troubleshoot it, the solutions implemented, and the results achieved. This documentation should be readily accessible to all relevant personnel. Finally, remember that continuous improvement is key. Regularly review your troubleshooting processes, maintenance procedures, and solutions to identify areas for improvement. Embrace new technologies and techniques to stay ahead of the curve and ensure that your induction heating system operates at peak performance. By following these best practices, you can minimize power supply failures, improve system reliability, and maximize the efficiency of your induction heating operations. And always prioritize safety. In addition to the above-mentioned points, remember to thoroughly check the power supplies themselves. Check for blown fuses, tripped circuit breakers, and any signs of physical damage. Check the internal components of the power supplies for signs of overheating, such as discolored components or melted insulation. Use a multimeter to check the voltage and current levels at various points within the power supply. Compare these measurements to the manufacturer's specifications to identify any discrepancy. Also, check the cooling system of the power supplies. Ensure that the fans are working properly and that the heatsinks are clean and free of debris. Overheating can significantly reduce the lifespan of electronic components and can lead to premature failures. Furthermore, consider the environment in which the power supplies are operating. Excessive heat, humidity, or vibration can all contribute to power supply failures. Ensure that the power supplies are located in a clean, dry, and well-ventilated environment. If the environment is particularly harsh, consider using sealed or ruggedized power supplies that are designed to withstand extreme conditions. Lastly, remember that power supplies, like all electronic components, have a finite lifespan. Over time, the components within the power supply will degrade, leading to reduced performance and eventually failure. If the power supplies are old or have been in service for a long time, it may be time to replace them, even if they are not currently showing any signs of problems. Replacing aging power supplies can prevent unexpected failures and ensure the continued reliability of the induction heating system. When selecting replacement power supplies, be sure to choose models that are compatible with the existing system and that meet or exceed the original specifications. Consider upgrading to more efficient or reliable power supplies to further improve the performance and longevity of the system. Remember to properly dispose of the old power supplies in accordance with all applicable regulations. Electronic waste can contain hazardous materials that can be harmful to the environment if not disposed of properly. By taking a proactive approach to power supply maintenance and replacement, you can minimize downtime, reduce costs, and ensure the continued success of your induction heating operations. and always prioritize safety when working with electrical systems. Consider the possibility of voltage transients and surges. Voltage transients and surges are sudden, short-duration spikes in voltage that can damage sensitive electronic equipment, including power supplies. These transients can be caused by a variety of factors, such as lightning strikes, switching of large loads, and malfunctions in the electrical distribution system. To protect the power supplies from voltage transients and surges, install surge protection devices at the main electrical panel and at the power supply input. Surge protection devices work by diverting excess voltage away from the protected equipment, preventing it from being damaged. Choose surge protection devices that are appropriately rated for the voltage and current levels of the electrical system. Also, consider using a combination of surge protection devices, such as surge arresters and transient voltage suppressors, to provide comprehensive protection against a wide range of voltage transients. Regularly inspect the surge protection devices to ensure that they are functioning properly. Surge protection devices can degrade over time, especially after repeated exposure to voltage transients. Replace the surge protection devices as needed to maintain adequate protection. Furthermore, consider the use of uninterruptible power supplies, also known as UPS. Uninterruptible power supplies provide backup power in the event of a power outage, preventing the power supplies from shutting down unexpectedly. Uninterruptible power supplies also provide voltage regulation and surge protection, further protecting the power supplies from damage. Choose uninterruptible power supplies that are appropriately sized for the power requirements of the power supplies. Also, consider the battery backup time provided by the uninterruptible power supplies. Select an uninterruptible power supply with a battery backup time that is sufficient to allow for a controlled shutdown of the induction heating system in the event of a power outage. Regularly test the uninterruptible power supplies to ensure that they are functioning properly. The batteries in uninterruptible power supplies can degrade over time and may need to be replaced periodically. By implementing surge protection and using uninterruptible power supplies, you can significantly reduce the risk of power supply failures caused by voltage transients, surges, and power outages, and always prioritize safety when working with electrical systems. In addition to the recommendations already provided, it is important to thoroughly investigate the electrical wiring and connections throughout the induction heating system. Loose or corroded connections can cause voltage drops, overheating, and intermittent power supply failures. Carefully inspect all electrical connections, including those at the main electrical panel, the power supply inputs, and the power supply outputs. Tighten any loose connections and clean any corroded connections. Use appropriate tools and techniques to ensure that the connections are secure and reliable. Also, check the electrical wiring for signs of damage, such as frayed insulation or exposed conductors. Replace any damaged wiring immediately to prevent electrical shorts or fires. Ensure that the electrical wiring is properly sized for the current levels of the system. Undersized wiring can overheat and cause voltage drops, leading to power supply failures. Consult the National Electrical Code, NEC, or other applicable electrical codes to determine the appropriate wire size for the current levels. Furthermore, consider the use of shielded cables to reduce electromagnetic interference. Shielded cables have a metallic shield that surrounds the conductors, preventing electromagnetic interference from entering or leaving the cable. Use shielded cables for all critical signal and power connections to minimize the risk of interference-related problems. Ground the shields of the shielded cables properly to ensure that they are effective. Improper grounding of the shields can actually increase electromagnetic interference. Consult with a qualified electrician to ensure that the electrical wiring and connections throughout the induction heating system are safe, reliable, and properly installed. Remember that electrical work can be dangerous and should only be performed by qualified individuals. Always prioritize safety when working with electrical systems. Ensure that the electrical system complies with all applicable electrical codes and regulations. Failure to comply with these codes and regulations can result in fines, penalties, and even legal action.